Today we are going to discuss two-port networks. First of all, what is meant by a port? A pair of two terminals. A pair of terminals is known as a port. Every network can be assumed in the form of a black box. Imagine within this box there is a network and two terminals I am showing on the input side of the box and two terminals I am showing on the output side of the box. Now this particular box with the two terminals on the input side and two terminals on the output side is known as a two-port network. The port on the input side is called input port and the port on the output side is called output port. Every network requires an input to operate. Basing on the nature of the network and basing on the elements of the network, it produces the output as per the given input. Hence, the input terminals of the input port, the conventional practice is to represent the input port voltage as V1 and input port current as I1. Similarly, the output port voltage and current, we represent them as V2 and I2. From now onwards, whenever we refer the input port voltage, we refer it as V1, the output port voltage as V2, input port current as I1 and output port current as I2. You also need to note an important observation here with reference to the directions of the currents I marked. The conventional practice of representing the port currents are like this. That means I1 and I2 both are shown into the network. But in reality, the current, output current I2 is away from the two-port network because the driving voltage is V1 and accordingly the driving current into the output side is away from the two-port network basing on the nature of the two-port network. The question here is, what is the importance of this particular network and what is the application of this particular network? Irrespective of the nature of the network, whenever we try to analyze that particular network, it is convenient by ignoring the nature of the network and by assuming that network in the black box, we can always analyze that particular network. What happens when we apply a voltage of V1 and what happens when we inject a current of I1 into the network? Accordingly, how much voltage we get at the output and how much current we get at the output. Every two-port network has two different types of functions which explains us clearly what exactly we are going to analyze from a two-port network. The network functions of any two-port network, they are broadly classified into two categories. The first one is driving point function network function, and the second one is transfer function. Any network function, it is ratio of Laplace transformation of a particular variable to the Laplace transformation of some other variable. Hence, numerator function is a Laplace transformation. Denominator function also is a Laplace transformation. Coming to the first network function, driving point function, it is the ratio of both numerator denominator belongs to the same port variables. It means, suppose the numerator is voltage of the input port, denominator is the current of the input port. When we take the ratio, both numerator, denominator belongs to the same port. In the same manner, whenever the numerator, denominator belongs to the output port, we say that that function is driving point output function. Suppose numerator, denominator belongs to the input port, we say that function is driving point input function. Whereas transfer function means numerator variable belongs to one port and denominator variable belongs to some other port. Suppose numerator variable belongs to input port. Obviously, denominator variable, if it belongs to output port, then it is one of the transfer functions. Suppose numerator variable belongs to output port and input variable, the denominator belongs to input variable, then it becomes one of the transfer functions. Hence, the first key point you need to register in your mind at this stage is the fundamental difference between driving point function and transfer function is, in case of driving point function, both numerator variable and denominator variable, they belong to the same port. And in case of transfer function, numerator and denominator variables belongs to different ports. Accordingly, let us analyze what are all various driving point functions for a given two-port network. So let us consider a two-port network with V1S V2S as Laplace transformations of input and output port voltages. Similarly, I1S and I2S, they are Laplace transformations of port currents. Now let us define clearly what are all various driving point functions for this particular two-port network. As I already explained, whenever we consider numerator and denominator variables belonging to the same port, that particular network function becomes a driving point network function. So, the first driving point function I can think of is V1S by I1S. See here, numerator is input port voltage. Denominator is input port current. Both variables belongs to the input port. Hence, the appropriate name we give to this network function is driving point input or input port. The short word here is input, or we can say input port. Look at this word, impedance. Whenever voltage to current ratio is considered, that function is called impedance. The unit of impedance is ohms. Ohm is the unit of impedance. Ratio of volts to amperes is impedance. Hence, V1S by I1S in future, whenever we refer, we read this as driving point input impedance. Impedance. The unit of this is ohms. Driving point input port impedance. Impedance. Let us consider the second possible driving point network function on the input side. Suppose I consider I1S by V1S. Immediately I can say this as one of the driving point functions. Why? Because both numerator and denominator variables, they belong to the same port. Which port it is? It is input port. Hence, the appropriate name for this network function is, it is driving point input port, or simply you can say input current to voltage ratio is called admittance. Hence, the function I1S by V1S, whenever we refer this network function, we call this network function as driving point input admittance function, or driving point input port admittance. What is the unit of admittance? You might have studied in your earlier classes. Mho, M-H-O, mho. But from now onwards, we represent this admittance unit as Siemens. Yes, symbol S represent Siemens. Earlier, you were familiar with the symbol like this, which is called mho. Now onwards, whenever we refer admittance function, we call that, we represent that unit as Siemens. Is there any possibility of having third driving point function on the input side? No, there is no possibility, because there are only two variables on the input side. One is V1S, second is I1S. And we can have only two possible driving functions on the input side. One is V1S by I1S, second is I1S by V1S. Now, let us represent driving point functions on the output side. If you look at the output side, there are two variables. One is V2S, which is nothing but the Laplace transformation of output voltage variable. The second one is the output current, Laplace transformation of output current variable. Now, the driving point function on the output side, I can think of one of the driving point functions as V2S by I2S. Numerator is voltage, denominator is current, and both belong to the output port. So what is the appropriate name we can give to this driving point function? It is driving point which port variables these are? They belong to output port. Driving point output port, ratio of voltage to current is known as impedance. Hence, it is driving point output port impedance. What is the unit of this function? The unit of impedance is ohms. So this is the third driving point function we can have for any two-port network. Suppose on the output side, when we consider the ratio of current to voltage, it becomes driving point output port, both belong to output side. That's why it is driving point function. And both variables belong to output, so it is driving point output port. The ratio of current to voltage is admittance. And just now we discussed the unit of admittance is Siemens, represented by S. So the conclusion here is every two-port network has four driving point functions. One is driving point input impedance, second is driving point input admittance, third is driving point output impedance. Fourth is driving point output admittance. There is no possibility of having fifth driving point function for a two-port network. What is the reason? Driving point always indicate numerator variable and denominator variable, they belong to the same port. Hence, there are always four driving point functions for any given two-port network. Now, let us discuss what are various transfer functions we can have for a two-port network and how to give appropriate name to each of these transfer functions. So, I am considering a two-port network with the port voltages as V1S, V2S and port currents as I1S and I2S. What is meant by transfer function? A transfer function is a network function in which the numerator variable represent Laplace transformation variable of one of the ports and denominator represent Laplace transformation variable of some other port. Both numerator and denominator are different port variables. They don't belong to the same port. Then we say that network function is a transfer function. Accordingly, let us identify what are various possible transfer functions and we give name to each of these transfer functions and we also identify what is the unit of each of these transfer functions. Imagine I am considering numerator variable as V1S and denominator variable as I2S. Just randomly I have written two variables. Numerator variable I considered V1S, denominator variable I considered I2S. The first glance itself I can say this is one of the transfer functions. On what basis I am confirming this is one of the transfer functions? Numerator and denominator variables, they don't belong to the same port. They belong to different ports. Obviously, it is a transfer function. Then, which type of transfer function is? Now, understand carefully. Whenever numerator belongs to input side, denominator belongs to output side, we call that transfer function as reverse transfer function. I repeat, numerator variable belongs to input side, denominator variable belongs to output side, then that particular transfer function is called a reverse transfer function. Hence, I call this as reverse it is a transfer function voltage to current is always impedance. The ratio of voltage to current is impedance. Hence, reverse transfer impedance function. The appropriate name we give to this particular transfer function is reverse transfer impedance function. What is the unit of impedance? Impedance unit always is ohms. So, whenever numerator belongs to input side, denominator belongs to output side, that becomes a reverse transfer function. Now let us write the second possible transfer function. I am writing V1s by V2s. At the first glance itself, we can say it is a transfer function because numerator and denominator variables, they belong to different ports. They don't belong to the same port. Accordingly, it is no doubt a transfer function. Not only that, whenever numerator variable belongs to input side, denominator variable belongs to output side, we call that function as reverse function. Hence, it is reverse transfer numerator is voltage, denominator is voltage. Accordingly, this is called as voltage ratio. Because it is representing voltage ratio. Numerator is voltage, denominator is voltage. Or we can also call it as reverse transfer voltage gain. Whenever numerator, denominator belongs to the same variable, we can also call it as a gain. Which gain? Voltage gain. What should be the unit of this voltage gain? Volts by volts. 10 volts by 5 volts. The answer is 2. It is a simple number. It has no unit. That's why it is a number. Whenever we say voltage gain or voltage ratio, it has some value, some constant value is no unit at all. Reverse transfer voltage ratio or voltage gain. Now let us explore what could be the third possible transfer function for a given two-port network. So the third possible transfer function I am writing Imagine I have taken numerator as I1s, denominator as V2s. I1s by V2s, when we consider, this becomes the ratio of current to voltage, and current to voltage, as they belong to two different ports, the first observation itself is it is a transfer function, and input by output, whenever we consider, as I already explained, this is a reverse transfer function. So, the appropriate name we give to this is reverse transfer admittance function, because current to voltage always represent an admittance function. Reverse transfer admittance function, and the unit of admittance, as we already discussed, it is a Siemens. The fourth possible transfer function, let us consider I1s by I2s. So what should be the name to this transfer function? It is driving point both are currents, numerator, denominators are currents. So we call it as, reverse transfer. This is both belong to different ports. So reverse transfer current ratio, reverse transfer current ratio, or reverse transfer current gain. And what should be the unit of this? It is a simple number, a constant value it has. So when we consider numerator as input variable, denominator as output variable, we have four possible reverse transfer functions. Reverse transfer admittance, reverse transfer current ratio, reverse transfer impedance, reverse transfer voltage gain. These are the four reverse transfer functions. Now let us consider V2s by I1s. Numerator belongs to output port variable, denominator belongs to input port variable. So the first observation gives it is a transfer function. Whenever numerator belongs to output side, denominator belongs to input side, we call that transfer function as forward transfer function. Accordingly, the name we give to this transfer function is forward transfer. That ratio is indicating impedance. Voltage to current ratio is impedance. Forward transfer impedance function and its unit is ohms. Imagine I considered V2S by V1S. It is a transfer function. Output by input always indicate a forward. So it is forward transfer voltage ratio or forward transfer voltage gain. What is the unit? The unit of this is constant. There is no unit. It is voltage to voltage ratio, hence it is a simple number. The name what we give to this is forward transfer voltage ratio or forward transfer voltage gain. Imagine I am considering I2S by V1S. So what is the appropriate name to this seventh function? It is forward transfer admittance. Why forward? Output by input is always considered as forward direction. Why transfer? Both belong to different ports. Why admittance? Current to voltage ratio is admittance. Forward transfer admittance function. Its unit is Siemens. And finally, the eighth possible transfer function is I2S by I1S. So the appropriate name we give to this transfer function is, it is forward transfer current ratio. Forward transfer current gain. It has no unit, it is a simple number constant, because numerator and denominator are representing current variables. So, if we look back into the discussion we had till now, any network, every network can be represented in the form of a two-port network, assuming that all the elements of that network are inside that black box. That network has two ports. That box has two ports. A port is a pair of terminals. Accordingly, the input side has input port voltage and input port current. Output side has output port voltage and output port current. A network in the two-port representation form can always be analyzed in terms of network functions. A network function can be of two categories. It is either driving point network function or transfer function. Whenever numerator and denominator variables belongs to the same port, that network function is called driving point function, and whenever the numerator and denominator variables belongs to different ports, that network function is called a transfer function. And whenever numerator variable belongs to input side, denominator variable belongs to output side, that transfer function is called reverse transfer function. And whenever the numerator variable belongs to output side, denominator variable belongs to input side, that transfer function is called forward transfer function. And the analysis of the complete network in two-port networks is considered in terms of analyzing these transfer functions and driving point functions. We stop the session today with the introduction of the driving point functions and network functions. రండి ఆపేసేయండి, అది కొద్దిగా ముందుగా వచ్చేసింది, నేను లేచాను, అది కట్ చేసుకోండి. అయిపోయింది అది. సరే, అది ప్లేబ్యాక్ చేయగలరా కొద్దిగా?
సరే సార్, చేద్దాం.